Speed limits might suck, especially after being called out and reprimanded for breaking them. However, speed limits, like all laws attributed to traffic, are in place for good reason, and they protect us and those around us. But there is one speed limit nobody can break, no matter how hard they try and how recklessly they drive. What am I talking about? The speed of light. But what is the speed of light? Well, let's not get ahead of ourselves. First, let's define what light is. Light is the natural agent that stimulates sight in the human eye. It is usually found between 400 and 700 nanometers. However, when I'm talking about light in this video, I'm talking about any form of electromagnetic radiation. Okay, we get it. But how fast is light? Well, as we've recorded, light travels at 300,000 kilometers a second, or 671 million miles an hour. But writing out the speed of light numerically or with words is a lot of hassle, so we just call it c. We chose the variable c to represent the speed of light because it comes from the Latin word for speed, celeritas. Alright, so that's the speed of light in a vacuum though, right? Because light travels slower in other objects, especially denser things. Actually, that couldn't be further from the truth. Light may appear to move slower when it goes through other substances, but it's actually self-propagating, which means it doesn't need a substance to move through to move at all. So light always travels at c. However, it only appears to move slower when in reality it only takes a longer path by bouncing off of other particles. So, do you remember the speed of light I told you earlier? 300,000 kilometers a second, or 671 million miles an hour? Well, the speed of light might actually be faster than that. At all times in space, there are particles that are equal of matter and antimatter popping in and out of existence everywhere around us. So it's theorized that the speed of light might actually be hindered by this, by bouncing off of those particles, and it may appear to move slower, just like it would through a glass of water, instead of a pure vacuum. Wait, so like, it could be infinite? Well, that's what Galileo thought, but you'd both be wrong. Einstein's famous equation, E equals mc squared, proves this. E stands for energy, M stands for mass, and C, as previously mentioned, stands for the speed of light. So, if the speed of light were infinite, then that would mean we would need infinite energy to create any mass. Then we know that can't be true because mass exists. And another reason we know that the speed of light can't be infinite is because we experience time. If the speed of light was infinite, then it would take no time to travel between any 2 points, so there would be no distance and everything would happen at the same time. So time wouldn't exist, and since time does exist and we experience a natural flow of cause to effect, that means the speed of light can't be infinite. Okay, so like, how did light get that fast anyways? So light never actually had to get that fast because light has always been that fast. Mass is considered an impediment, which means anything with mass can never move at the speed of light. However, anything without mass, such as a photon, a gravitational wave, or a gluon, those things can only move at the speed of light. They've always moved at the speed of light, they never accelerated and then never decelerated. The closest any person has ever gotten to see was the crew of the Apollo 10 mission in 1969. They almost hit 25,000 miles, which would be about 0.0037% the speed of light. But we got even closer with an unmanned vehicle in January 2020. The Parker Solar Probe hit 245,000 miles an hour, which is an unfathomable 0.036% the speed of light. Hey, well, we're getting closer. We got what, like 10% better in 50 years? If that keeps up, we'll be at sea in like less than 150 years. Who's to say that anything with mass can't travel at sea anyways? They probably haven't tried hard enough. Well, if you think about it, it really isn't possible. Mass and matter are held together by electromagnetic interactions, and those electromagnetic interactions themselves travel at c, the speed of light. So, how can something move faster than the force carriers that make it up? It's really impossible. This fact is where, in my opinion, the better name for the speed of light comes from. The speed of causality. The speed of light and the speed of causality are the same thing. The reason it is called the speed of causality is because c is the fastest anything can happen in our universe. Because since the force carriers move at that speed, it is the fastest speed at which anything can cause any other thing to happen. Hence, the speed of causality. Okay. So, I'm giving you a lot of numbers, and I'm giving you a lot of facts. But let me give this to you in a way you can understand. But first, I want you to take a guess. How far do you think the speed of light can go in 1 second? Go ahead, guess. Okay, so if you're traveling at sea, you could travel around the Earth 7.5 times in 1 second. Now, that may seem pretty fast, but the Earth is pretty small. So if you really think about it, the speed of light is kind of slow. To get from the Sun to Jupiter would take you 45 minutes. To get to just the edge of our solar system, 9 months. The closest solar system to us will be a 4.37 year trip. But these measurements assume that you don't accelerate or decelerate. In reality, these trips will take much longer so that you don't instantly die upon speeding up or slowing down. Alright, so what's the point? Clearly you're not getting anywhere interesting with this rule. But you didn't let me finish. So, there is a catch that may make it worth it. Time dilation. The faster you go, the slower time passes for you. As you approach sea, time gets slower and slower for you until you hit sea, at which point time ceases to pass for you. That means that from an outside observer, the trip from the Sun to Jupiter may take 45 minutes, but for you, no time would have passed at all. The trip would be instantaneous, like that. Photons and massless particles experience no time at all, and in a way, distance doesn't exist for them because all of their trips are instantaneous. They can be at any point in the universe to any other point in the universe, and for them, no time will have passed. In a way, this makes time travel possible, but only to the future. For example, if you traveled for 45 minutes at 99% the speed of light, then 45 minutes may have passed for you, but for everyone else on Earth, 5.5 hours passed. When you got back to Earth, you'd be 4 hours, 45 minutes younger than everybody else. The faster you go, the bigger this disparity becomes. Wait, so if time slows as you approach sea, and time stops when you hit sea, if you could pass sea, would time go in reverse for you? Yeah, that's exactly what scientists hypothesize. Sadly, as far as we know, it's still impossible. Alright, so there's a lot of hypotheticals tied to the speed of light, and it seems like I'm never actually going to benefit from the effects of it, nor experience any of it. Is there really any way we could use this knowledge now? Yeah, so there's actually one great example of the speed of light being used to benefit people right here in New York City. There's a stock exchange about 5 blocks away from Wall Street, and it's called IEX. IEX coiled up 38 miles of fiber optic cable and revolutionized the stock trading industry. Fiber optic cables use light to transmit data. That means that anybody trying to access IEX has to wait at least 350 microseconds to get from point A to B and travel through that coiled wire. The reason IEX did this is to level the playing field between people trading and machines trading. Over the past couple of years, algorithms have been trading stocks more than people and more effectively. One of the newest tactics to get the best price for your stock is to find out what somebody else is trying to buy it for, take their price, and get to the stock exchange faster with that price, all with machines. IEX has created a speed bump, allowing nobody to go faster than 350 microseconds. But what does 38 miles even look like? 38 miles is about as far as it takes to get from Queens, New York, to the Jersey Shore in Perth Amboy. And if you've been paying attention, that's exactly what that time lapse is showing you. Maybe it's not so bad we can't go faster than the speed of light. But hey, don't worry, I'm sure we'll find a loophole.